The National Council of Teachers of Mathematics welcomes you to Adding It All Up, a podcast created by and for mathematics educators and teachers. Join us each month as we explore current topics, insights, and emerging trends with thought leaders in the math community. And now, the hosts of Adding It All Up, NCTM President Latrenda and NCTM President-elect Dewey Gottlieb.
Hi, everyone. Welcome back to Adding It All Up. It's already April. We're a quarter of the way through 2026, and April is Mathematics and Statistics Awareness Month, which feels like the perfect time for us to reflect on how the role of mathematics is constantly evolving, not only in our classrooms, but in our lives and in our students' lives. We're not just teaching procedures anymore. We're helping students interpret data, be critical thinkers, be critical consumers of information, question that information perhaps, and make sense of the world around them and change their mind when they're presented with new information, if possible. That can feel like a really big shift for us in our classrooms as mathematics teachers and how we incorporate that in our curricular programs that may not always emphasize that. In my own experience, when I was a high school mathematics teacher, whenever I brought in data into lessons, it really changed the energy in the classroom. At the end of the school year, I would always ask students, that kind of a little on this feedback form, what was your favorite or most memorable learning experiences or activities from the year? And every year, the activities, as soon as pointed out, was those activities where they were either generating their own data sets or doing some research to find some data and doing some data analysis activities in real world context. So I found that it really made an impact on students' experiences with mathematics. And not only just to come up with answers to the questions that I was posing, but provided opportunities for students to engage in deeper discussions, have some productive confusion that try to make sense of the data when things weren't aligning with what they were maybe some conjectures they were making ahead of time. But it definitely pushed students beyond just doing procedures and getting an answer.
One of the things I love about being able to have authentic data and using those as investigations of students is it really helps students to see the relevance in mathematics. In my experience in working with students that I taught and students that I support in other teachers' classrooms, I found that when we engaged in investigations where students were able to actually construct the data. They were able to choose the questions to answers, the things to explore. That first of all, there was more buy-in. It was relevant, and students were openly and eagerly discussing those situations that they were talking about. And so it makes so much more sense than just having this chart or graph for elementary students where this random person is, for some reason, making a graph of sorting toys or sorting pots or something that really doesn't make any sense and is not of very much interest to a child who's 9 or 10. So, one of the things that it really becomes evident is that students no longer see it's just about speed or just numbers on a page. They really begin to think about reasoning, they think about problem solving, think about critical thinking, and they think about how can I question things that are given to me? How can I pose questions to find out information? And how can I construct this so that it makes sense? And I found that they would ask better questions. One of my favorite things to do, and I have to be honest, when I thought of this investigation, it was more out of, okay, I need a project for these students to do because I need to challenge them. And I've got like probably 20 minutes to come up with this big project so I can send them off with this big assignment. And so I decided I'd have my fifth graders to actually conduct investigations where they each had to come up with a question that they felt would be of interest either to other students or to members of our community. And they had about a week to conduct their investigations. And then they were challenged with they had to find a way to present and share the data with us in a way that made sense. So first there was a little bit hemming and hawing, but they really got into it. And I was pleasantly surprised at the types of things that they chose to investigate and really the relevance and how they were so aware of issues that were important to either Other students are things about the community that they lived in that they wanted to explore, they wanted to question. So it really changed my outlook on those investigations. And I began to bring those types of things into my regular practice just by thinking about that. So it's one instance where I really learned from my students about what things were important to them and things were relevant. And because I didn't live in the community, I didn't know a lot about the issues that they were facing. So it really made me more cognizant of their lived experiences as well. So it really was a positive experience and learning experience for me as a teacher as well as for them. So I would think this month that's dedicated to mathematics and statistics, it's really important for us to really think about what students really want and what students to take away from those type of investigations. How do we make sure that they are being critical thinkers, they're being problem solvers, and they're really thinking about how do I navigate and make sense of all the data that I'm bombarded with on just a daily basis. So it's a great opportunity for us to showcase these investigations, but also to think very intentionally and purposely about those.
Agreed. Thinking about not just today's world, but we're preparing today's students to live in and thrive in the 2030s, right? And we can't predict what that means. But just thinking about just today's world, and we have tools, for example, like artificial intelligence tools, and the things that that can do for us. That just changes what the learning experiences that we might want to provide for students, how we might want to have students use those tools in an ethical and manner, but also how might that support the experiences we want students to have in mathematics classrooms, which also forces us to consider what mathematical thinking really means for the world that the students we want our students to be prepared for, and how to help students kind of navigate through all of this information, thoughtfully.
That is such an important point because one of the things that I would often tell my students is that you don't want to go through your life as a passive learner and just have things provided to you and given to you. You want to be able to question those things, to ask, do they make sense? Is it relevant? And actually make sure that the information that you're being given is correct and take an opportunity to critique how it's represented. Because sometimes how someone chooses to represent the data could have something to do with how you actually interpret the information. And so that's one of the reasons why we're extremely excited to have Ken Ono joining us today to share his perspective on math, data, and AI, and how all of this connects back to thinking mathematically. So, Ken, at this time, to welcome you to Adding It All Up. And if you don't mind, would you please tell our listeners a little bit about yourself?
Thank you, Latrenda and Dewey. It's delightful to be here. My name is Ken Ono. I'm about to turn 58. I've been spending most of my career as a professional mathematician with a number of side hobbies. So I'm a professor at the University of Virginia, and I'm the founding mathematician at an AI company in Palo Alto called Axiom Math. I'm looking forward to our conversation, talking all things mathematical.
Ken, we're really excited to have you with us today on the podcast. I'm familiar with some of the things that you do. I know you've had amazing impact on mathematics in a variety of areas. And so as we're really excited to be able to have this conversation with you today. One area in particular that we were excited to chat with you about is because we know you've applied mathematics and data analysis in real world performance settings. For example, your work with elite swimmers at the University of Virginia, and their performing as world-class athletes beyond just the University of Virginia. Can you share an example of how data meaningfully changed an approach or an outcome in the work that you've done?
Oh, yeah. This is kind of a love affair. When I was a kid in high school, my dream was to be a professional bike racer, but that never happened. So, over the last 10 years, it's been a dream come true to apply mathematics and some physics and data science to Olympic sports. It all kind of happened by accident. I work with the University of Virginia varsity swim team that has now won 6 consecutive national championships, and between the Tokyo and the Paris Olympics, by the way, I got to go to the Paris Olympics, and that was really a dream come true. The athletes that we sent won 20 medals, and every athlete that we worked with came home with a medal between those two games. So you might ask, in what way does math and data science help elite swimmers? And I don't think the sell is very difficult. There was a very popular movie not that long ago starring Brad Pitt and Jonah Hill called Moneyball, where the film tells the story of how data analytics could help the Oakland Athletics become a championship caliber baseball team. And what you learn from that story is that if you're good at collecting data, very detail oriented about trying to spot patterns in the data, you can improve a sport. You can improve a team's performance. And in the case of elite swimming, it's even more perfect because you don't have to worry so much about how a team of athletes can form to become a better team. The problem is much simpler. How do you optimize the performance of an athlete performing a particular event, say 50-meter freestyle? And so we live at a day, an age where we have much more technology than just a stopwatch, and certainly much more technology than just video cameras. We're able to attach sensors and force paddles to the athletes, which create a digital twin of an athlete performing their very best in practice. That digital twin captures the force that the athletes generate in their strokes. It also measures the unnecessary deceleration, which you don't want an athlete to experience in swims. And we feed that data into our machine. We produce a digital twin. And with that digital twin, we run many, many, many different simulations where the idea is that we can spot potential targets of opportunity that will improve performance. We go back to the athlete. Now we do it in real time because our sensors are equipped with AI, which beam the messages to an iPad on the pool deck. And a coach in real time can offer suggestions for both training sets and more importantly, in execution. So if you can cut drag and streamline an underwater by a tenth of a percent, you'll take it. And that's all data analysis combined with physics and Newton's laws of motion.
Exciting.
That is so fascinating. I am an observer of sports, not a participator, but I'm someone who is always fascinated. And when I talk to those students who are involved in competitions, it's great to find out how much math they're really doing. What are some patterns or insights this math reveal in sports that maybe some of the coaches you've worked with or the athletes may not notice on their own?
So there's many long lists. Let me start with an obvious one. If you want to be an Olympic swimmer or an elite swimmer, it doesn't help if a coach tells you Katie Ledecky swims this way, so that's how you want to swim, or Michael Phelps swims that way, so go swim like him and study his YouTube videos. I'm sorry if you don't have Katie Ledecky's build or Michael Phelps' build. You might get fast, but you're not being the best you that you can be. And so the number one lesson here that all math teachers are quite good at is attention to detail, attention to the process, attention to how do you optimize yourself. So, as a swimmer, you might ask, how many strokes should I take to cross a 50-meter pool in, say, freestyle? You might think that that's a magic number that's fairly rigid and fixed across athletes, or maybe fixed by gender. Oh, that's not true. Or in breaststroke, one of my current graduate students, Kate Douglas, she's also a world record holder. She has 4 Olympic medals. She swims an event called the 200-meter breaststroke, which is very, very difficult. And so if you were to watch Kate Douglas swim that event, say in the Olympics, you'll think she's taking far fewer strokes than everyone else in the pool. I wonder why that is. It's because she has this very unique combination of body characteristics that allows her to float on top of the water much better than anyone else. And so maximizing the distance per stroke for her is what leads to Olympic gold. Whereas if we were to apply that same formula and frequency to others, they would be sinking in the water, going a whole lot slower. It's funny, I could feed the video of the top 100 breaststrokers in the world and try to have AI come up with the right formula for a swimmer, and it would do a horrible job, right? You don't want your librarian to be your neurosurgeon, just like you don't want your librarian to be your Olympic coach. Your expertise matters. So for our conversation, your AI needs the math teacher who will fine tune the dials to reach perfection.
I love that. I love that. Thank you.
Yeah, that's such an exciting connection to be made. And side note, I was a swimmer growing up. I swam competitively, so I'm a big fan of swimming. I know some of your swimmers. Big fan of Kate Douglas and her teammates, and her breaststroke is amazing.
It looks like she's not stroking, right? It looks unfair. You want to hear an amusing fact, Dewey? It's going to sound impossible to you, but she has this remarkable ability to even move the air in her lungs upward in her chest to allow her to float for longer. I've only seen that in one other athlete. Yeah, only seen that in one other athlete who also was an Olympic gold medalist.
And you were able to measure it. How
And,
cool.
and we have the ability to measure that. That's right.
That's so amazing. Wow. When we talk about this idea about thinking with data, what does that mean in the context of, if we can talk about teachers, classroom teachers, mathematics teachers, for example? How can we help teachers go beyond just thinking about calculating with numbers or producing graphs? Beyond that, how might teachers help students develop that kind of thinking with data?
Oh yeah, I mean, wow. In 2026, this is the year of disruption because of AI. And at the University of Virginia, we were thinking very deeply the last couple of years about how to rethink education. And with the emergence of ChatGPT or Claude or Google Gemini, you have this illusion that knowledge is somehow now very cheap, right? The pursuit of the answer is somehow very cheap. And that's horrible because what you want to teach in your math classes isn't that, oh, I can factorize quadratic polynomials very quickly. To the end of the day, it's really the thought process that we really cherish the most. So to answer your question, I think we all have to think very deeply about what it means to be human, what it means to be creative, and what it really means to inspire a sense of wonder. If you have an infant in the home, a 1-year-old infant is playing with blocks. Those blocks probably have letters on them. They probably have numbers 1 through 9 that mean nothing to the kids, right? 1 through 6, rather. But what might they be doing? They might be stacking the blocks up, pushing them over, giggling when the blocks pull over, and then they'll do it again. Where is that sense of wonder that is lost in a rigid educational system? We all believe in standards because the standards are the benchmarks by which we assess knowledge growth. But now that knowledge has become somehow cheaper, and it was already starting to do that with Google, I think we need to think about how we adopt the AI tools with an eye for spending quite a bit more time emphasizing wonder, emphasizing what is human, emphasizing what is creative. And the stories that we were just talking about, how do you make an Olympic swimmer an Olympic champion? How do you amplify and augment the human? Just like, well, back in the day, it would have been reducing physical effort because of the introduction of machines and engines. Now, how do we do that? Let's talk about that more, Dewey.
I love that. Absolutely. Yeah. Just thinking, how do we engage the students in experiences that allow them to think in those ways? It's far beyond what we might find in our textbooks.
And it's probably very individual, right? In a class of 20, you might teach 20, 25, say middle schoolers. For some, the beauty of mathematics is best taught through arts. Maybe for those students that think in rainbows and butterflies. But then there was others that love sports and they can rattle off statistics from their Major League Baseball teams. And for others, could be something as simple as Minecraft. I really wanted to come up with a new algorithm where I'm building the world mathematically on computer in Minecraft, and they come up with their own algorithms. This might not sound like math, but math is everywhere. And in your role, Latrenda and Dewey, think about what inspired not only you yourselves when you were students and later as teachers, but the collection of all the stories. Because what might speak to a student might not speak to their classmate. I think we need that.
Registration is now open for the NCTM 2026 annual meeting and exposition, happening October 28th to 31st in Denver. More than 5,000 math educators will gather around this year's theme, Mathematics for a Changing World, Belonging, Learning, and Leading, to share ideas that will help you thrive, create practical strategies for your classroom, use technology thoughtfully, and strengthen teaching for every student. Come for the ideas, leave with inspiration.
Learn more and register at nctm.org/Denver 2026.
Ken, I felt like a kid watching and listening as you were talking about the importance of actually honoring each student and how they see mathematics and how they experience mathematics, thinking about the wonder, joy, and beauty of mathematics, and how some of us became excited about what we do. Think about how, especially today, how it's very different than what I was taught as a kid. That outside the traditional classroom, we have an opportunity to see how math and data science are being used, how they're connected, specifically in some of the examples you've mentioned, like in health and sports, and more importantly, in just everyday decision making. What makes you excited most about how we are seeing that interplay of math and data science?
What's interesting about that is I think we are at a very special moment in the history of mankind. That might sound kind of extreme, but let me explain. When I was going to high school in the 1980s, the courses that we took were all very standard. It was Algebra 1, Algebra 2, geometry, and maybe some calculus. We still use those terms today. And when we think about the courses that we teach today, we still use those words, but the courses look very different today from what we taught earlier. You now introduce concepts from data science in the classroom because you need to be data literate to navigate this world. And with the emergence of AI and the phrase, what does the data tell you? We live at a time where people want and demand quantitative stuff. And that's very different from the 80s. And what I like about that is, on the one hand, the world is demanding that our students graduate from high school with real data skills. When I was in the 1980s, it wouldn't have been okay to say, oh, I don't write well, but it was okay if you weren't any good at math. But today, it's kind of flipped, right? A large language model can write poetry, can write a novel, but you really do need to know how to navigate your data. So I think this is a good opportunity for us as mathematicians and math educators to recognize that the world has kind of woken up. We know that the world is modeled by mathematics. Maybe the math that we teach doesn't look like what was taught in the 70s or 80s, but that's not a negative. It's a positive. It shows that the policymakers and those who are assembling the curriculum are thinking about how to prepare our students best for the modern world. So whether that is in elementary school, taking kids to a science museum where they learn about the orbits of planets, or whether it's the data that enhances and informs athletics, or whether it might even be introduction to politics, where you teach everyone that their vote counts. There's so many reasons around that indicate that math and data is just super important.
I agree with you. We need to take advantage of this moment and capitalize on it as much as possible because it's a great opportunity.
Right. Well, in high stakes situations, you ask, what does the data tell you? You want to make sure that you know how to interpret the data correctly. And as math teachers, we want our kids to not only show their work, but understand why they are showing their work. And at a time where, as I said earlier, knowledge seems to be cheap, large language models are often competently wrong. They're competent, and even when they are wrong. And this is an opportunity for us as math teachers to say, this is why we wanted you to show your work. It's not about just getting the right answer. As important as that may be, how do you know when you are wrong? And we live at a time where verifying computer code, verifying the use of AI might be one of the most important challenges of modern times.
Just kind of putting into the context, as you said, like being able to navigate in today's world, considering the modern world. Now, this idea of helping students become strong thinkers, data thinkers, for example. It goes beyond just a lot of the skills, the mathematical skills and procedures that we have historically taught in math classes. But beyond that, They're thinking about some of these ideas you've been talking about. What might be some of the habits of minds or skills? What you've been talking about with us so far is getting at those ideas, how we want students to engage with their world. What are some of those habits of minds or skills that you think are most important for students to develop?
Yeah, I've already touched on the importance for need to pay attention to detail, to not assume information that you are given is automatically going to be correct because it came from a computer. So, critical thinking skills, understanding orders of magnitude, they are common sources of error that a good education in mathematics can address. But I'd like to go back to what it means to truly be human. If we could teach our science classes, our math classes, our data science classes in a way so that our students leave the classroom and walk down the streets in their hometowns wondering about, oh, I now understand why that building was built that way, or I can see why the architecture in this bridge had to be this way because I learned the principle in a math class that helps me understand my world a little bit better, or even understanding how linear algebra might be used to manage traffic patterns in like downtown Honolulu for you, Dewey, right? Mathematics is meant to assist and augment mankind. It doesn't always work, but if we could inspire curiosity and wonder in our kids so that they can spot where math is at use and where it could be better put to use, makes everything that we teach relevant. And I don't know exactly how we would do that. I think it largely will depend on the personalities of the instructors and the kids class by class, but I think that's very important.
For sure. You just reminded me of something that I learned and I was a little humbled by. And I think at the Student Achievement Partners, the meeting that we were both at, the High School Mathematics Education Summit, I remember in my small group, we were talking about how much matrices should students be expected to learn. Is matrices a topic for all students? And if it's so, how much of it? And there was this clear divide on our table between the K-12 folks and the higher ed folks. It took us a while to realize when we were talking about matrices and linear algebra, we weren't talking about the same thing. I know the high school folks had this very procedural thing of doing row reduction and all that manipulation and determinants. But then the higher ed folks are saying, no, that's not what we're talking about. And it opened up my mind so much. And it was humbling to realize that.
Well, thank you for having me on this podcast because my life experience as an educator has been at the college level. And so the terminology that we use in college and the terminology that's used in other education spaces, the words may be the same, but our context is completely different. And one thing that I think is important about the work that we were doing in DC is to face that head on and recognize that, well, if high school policymakers, high school math teachers aren't communicating with the college math teachers, how do we know we're doing our very best to accommodate our students as they transition from high school to college? There's no way that we could be doing that well. It's just your parents would say, if you don't walk a mile in someone else's shoes, how do you have the right to assume you know anything about their experience? And so, yes, thank you for having me on this podcast because that's something we certainly face at that meeting head on.
Absolutely. Yeah, that's critical. And even just to kind of circle back to what you were saying earlier, it's about what makes us human. It's understanding that human perspective or putting it in that perspective of what it means to be human.
We need fewer reasons to be siloed. We need fewer reasons to be divided, in particular at this time. And this is the one thing that we're fortunately good at in mathematics. We are too good at classifying. You are such and such because the definition says so. You are such and such because the definition says so.
But
Let's
our
remember
systems don't need that.
exactly.
Ken, this has been a wonderful conversation. So I want you to think about from your perspective as a mathematician, and you've talked a little bit about this, but specifically, how is AI changing the way people approach problem solving and analysis?
Oh, that excellent question. There are several points I wish to make. The first point I wish to make is that AI is happening. It's not going to go away. So, for educators that have not yet engaged or are worried about how they might introduce AI into the classroom, it's just going to happen. But that's not a negative. The negative would be to assume that the AI, like calculators back in the day, will just solve problems for students, making what might be taught in class irrelevant. But we use calculators, and I don't think any of us think that the introduction of a calculator by any means made math courses either less interesting or irrelevant. But you may remember, or maybe I'm older than everyone here, when that was a significant concern. On the other hand, let's make no mistake, what AI can do greatly eclipses what calculators can do. So we're at a period of disruption where we have to rethink what education should look like. Now, on the one hand, AI, and like I said, is often confidently wrong. So don't assume that what an AI large language model is giving you is correct. But despite that, AI tools, ChatGPT 5.4 Pro or Google Gemini, are remarkably accurate, and they're only going to improve over time. And so, does that mean that we don't teach our students the basic methods of manipulation in solving traditional math problems? Of course not. I drive a car every day and I don't know the chemical processes that make the car work, and I don't feel bad about that. But make no mistake, basic mathematical skills should not be mistaken for what I just described in terms of the complicated structure of the motor engine. So, maybe what we want to think about in our education and our policy is a hybrid. And I've been learning recently a little bit about the system in Australia, and I'm not an expert, maybe that many others are, but I just learned recently that in Australia, they don't even allow students to use AI tools until a certain age. Maybe it was 12 or 16, I don't quite remember, and I don't know what the policy exactly is, but they definitely understand in Australia that process and intuition is better developed by actually manipulating numbers and objects with your hands, right? It's like the 1,000-hour rule. If you've spent 1,000 hours working on something, you'll develop some natural intuition, which I don't think anyone would agree would be something you want to discourage in your students. Now, what does that look like? AI, if you were trying to teach a concept in mathematics and a student struggles with a particular type of explanation, a good teacher can explain something 3 or 4 different ways. And that's what we hope for. But how do we take advantage of the AI's tools when the teacher is no longer there? Like at home, when the student is doing homework, that's where the AI can step in and be that super tutor and offer 7, 8 description to a problem and eventually help the student find the right way to master a complicated topic. That's what I think will work best here. When I described what we do with our elite swimmers, it's not like talking to my elite swimmers about how they change their stroke. It was the AI in our devices collecting data, informing the world's best coaches about what looks like imperfection in the pool. And it's the coach saying, change this, change the angle of your hand entry. And maybe it's that kind of hybridized approach that is what we will be eventually aiming for.
Using it as a resource, but not as
Right.
a crutch. Yeah, I love that.
I mean, let's face it. How often do we teach classes where breaking the ice, developing the rapport with your students is challenging, right? For me, when I teach my courses, I hope and pray that on the first day of class, those 2 or 3 students that are going to be the hands up every time are there to help me develop a comfortable classroom environment. It doesn't always happen. And why is it? Because you're asking a lot of a student to say, "Oh, I don't know how this works. Teacher, could you show me how this works?" You're asking someone to reveal that they don't understand something, and that can be uncomfortable. But in the comfort of your own home at night when you're working with AI, I've never met someone that isn't willing to say, "Dear AI, can you help me with this project? I'm embarrassed to show you what I don't know." And I think that's a feature that breaks down barriers. Yeah, so what will AI look like in the future? I don't know, but I think it will play an important role.
Thank you so much, Ken. This was just a fun conversation, very provocative. I love it when I'm forced to think differently, and just appreciate you for being here with us. Thank you for being a leader and an innovator in mathematics and giving us lots to think about, trying to paint a new vision for what mathematics could be for us as mathematics educators. So we appreciate you. And thanks for spending the time with us today.
Well, my pleasure, but I appreciate you because I 2 kids are now adults, and I saw firsthand how math education was very different from them in the 2010s than it was for me in the 80s. and it launched their careers and made the college math kind of a breeze for them. So thank you for what you do.
Oh, nice. Thank you for sharing that story. I'm going to take what you just shared and send that to our listeners. All you teachers out there listening here, we want to share that appreciation and love that Ken just expressed and send that out to all of you. So thank you for joining us, everyone. Thank you, Ken. We'll be back next month with another great episode of Adding It All Up. Hope to see you then.
Thank you for listening to this episode of Adding It All Up. At NCTM, we strive to bring you the biggest topics happening in mathematics. Join us next month for another exciting discussion.